are you? I hope you are doing good, and I hope that you are listening the classes regularly. And in the last class, we are discussing about the concept of the iteration method. So in that iteration method, the procedure will be different now. Already we are started one application, right? So now that application is nothing but, what is the question? X cube equal to 1 minus x square, right? So now of course already I discussed this application half of the part. Again I am going to discuss this one. So now here x cube plus x square equal to 1. Okay, so now here I am taking x square common, then x plus 1 equal to 1. Now x square equal to 1 by 1 plus x equal to 1 by under root of 1 plus x. So it is of the form x equal to pi of x. So therefore pi of x is equal to 1 by under root of 1 plus x. So now here finally we have the value of the pi of x. Okay, so next here we have to calculate pi dash of x. Now pi dash of x is equal to, now it can be written as 1 by root x, means otherwise we can write that pi of x is nothing but, in a previous class I said that it is 1 plus x whole power minus 1 by 2. Now pi dash of x equal to minus 1 by 2. 1 plus x whole to the power of minus 1 by 2 into, minus 1 by 2 minus 1. Next into inner function derivative is 1. So now minus 1 by 2, 1 plus x minus 1 minus 2. That is minus 3 by 2. Okay, so now it is nothing but pi dash of x. Now here we have that the value of the pi dash of x. Now I am taking that modulus of pi dash of x. That means 1 plus x whole to the power of minus 3 by 2 by 2. Because modulus means we have to take that only positive value now. Now minus means here simply 1 by 2 of 1 plus x whole to the power of 3 by 2. Okay, this is nothing but modulus of pi dash of x. And I consider here the interval as nothing but 0 and 1 now. So 0 and 1 means if you put x equal to 0, then what you will get? I will get that it is 1 plus 0 means 1. So 1 power something will be 1 only, right? So now here I am writing it as nothing but 1 by 2 of 1 plus x whole cube whole power 1 by 2. Okay. So now here we have that the interval is nothing but 0 comma 1. When I am taking 0 and 1, the 1 is nothing but the maximum value, supremum value in the interval, and 0 is nothing but minimum value. Now if I put x equal to 0, then what I will get? Pi dash of x at x equal to 0. It will be 1 by 2 of 1 plus 0 is 1, whole cube is 1, whole power 1 by 2 is 1. Now simply it is nothing but 1 by 2, 0.5. Next, pi dash of x, when it is at x equal to 1, then 1 by 2 of 1 plus 1, 2. 2 whole cube whole power 1 by 2 equal to 1 by 2 into 2 cube means 8. So 8 under root of 8 means it can be written as 2 root 2. That means 4 root 2. So now by taking the calculation, just calculate that 1 by 1 whole divided by open bracket 4 root 2. It is nothing but 0.176 now. 6, 7. Now therefore here the maximum of pi dash of x. So here I am taking that the maximum value. Okay. That is nothing but, of course, here we will get that 0.5. But at x equal to 0, we are getting 0.5. And x equal to 1, where the maximum pi dash of x is nothing but obviously this one. But here what we have to take? We have to take that at a maximum x. So now here what is the value? Of course, here it is nothing but 0.1767, which is less than, otherwise simply what we can say, approximately what I consider that it is 0.2, of course, which is less than k. Okay, so next here simply what we have to calculate, the remaining values, right? Now for that one, of course, we consider that the error also, xn minus 1 and so on. And now here I am taking that the modulus of xn minus 1 by here what we have to consider, generally we have to take that xn minus 1. Like x3 minus x2 by x2. We calculated the error, but here we took that it into some 100%. But I'm not taking that one. Now xn means obviously what we know, xn is nothing but the maximum value. That is 1 minus 0.2 by 0.2. Now what will be the value? Already we calculated now. It is 4, right? Now which is less than or equal to 4. Now what they mentioned that 10 to the power of 4. So given 10 power minus 4. Therefore 4 into 10 to the power of minus 4. So into 10 power. Okay, I said that how to consider this value, right? So 10 power minus 4 means it can be written as 1 by 10 power 4. That means 0.0001. So now 4 into 0.4 power 4 number. So how many zeros we have to take? 3 zeros. Now it is 0.4 means 1, 2, 3. 3 zeros. Here what we have? 4. This is the value we have. Okay. So next write down here. So up to here we discussed, and I said that we have to consider in the procedure. What they mentioned to consider one value for x0. So what they mentioned clearly, x0 is a approximation value. Okay. So now here choose, write down, choose an approximation for x. Therefore x not equal to 0.75. Why I am taking? Because the interval is 0, 1. 0, 1 means 0 plus 1 by 2 is 0.5. I am taking that greater than 0.5. That means, see here, 0.5 plus some 0.2, 0.7. So nearly I am taking. Okay, we record the a value and this question. And I will say for different problems, I will consider the different values also. Okay. Now here I have the x0 like this. Now what we have to calculate? X1. So x1 means, where is pi of x? This one. So now x1 means 1 by 1 plus x under root of 1 plus x now, because here we have to take that x is equal to pi of x. Now to know about this one, we have to put x0 here. So then what I get, which is equal to 1 by 1 plus 0.75. So now calculate 1 by 1.75. Under root we have now 1.75. We have that the answer is 0.75592. So I am taking up to 4 decimals. Next, this is therefore x1 equal to 0.7559. Next, what we have to do? x2. x2 means 1 by under root of 1 plus x1. That means 1 by under root of 1 plus 0.7559. So which is equal to what we get here? 1 whole divided by open bracket under root of 1.7559. Now I got that 0.75465. So I am taking that 4 step. Now this is nothing but x2. So here 7575 up to 75 it is same, but next one again we have to go for the next iteration. So x3. x3 means 1 by under root of 1 plus x2. Now 1 by under root of 1 plus 0.7547. Now 1 divided by under root of 1.7547. Now which is equal to, okay, so here I am writing 0.75491. So clearly I am taking that 49 and this is nothing but x3. Obviously 3 digits are same, right? So now here 3 digits are same, and next here we have to calculate the next one. Otherwise, you know, here what we got 0.754, 0.754, and in the question what they mentioned up to 4 decimal places now. So that's why here I am going to calculate one more iteration. x4 equal to 1 by under root of 1 plus x3. 1 by 1 plus 0.7549. Now calculate it. 1 whole divided by open bracket under root of 1.7549. Now here it is nothing but 0.75487. I am taking 487. That means 0.7549. Okay, clearly we got that same answer. Therefore, the required root is 0.7549. So now what is the meaning of this iteration method? Just we have to put that the previous values in a pi of x. That's it. Then we will get the new values. So now next write down. We have another problem. Write down. Find the real root. Find the real root correct to the 3 decimal places. 3 decimal places of the equation 2x minus 3 equal to cos x lying in the interval 3 by 2 comma pi by 2. 3 by 2 comma pi by 2. Okay, so now here clearly what they mentioned that the function and they mentioned the interval. Now before going to start this problem, 3 by 2 means obviously we know that 1 by 1.5. The next pi by 2 means already here you have the button pi divided by 2, then it is 1.570. So now the interval is 1.5 to 1.57. Very near interval, right? Now here, simple problem. Now given that 2x minus 3 equal to cos x. 2x equal to 3 plus cos x. X equal to 1 by 2 of 3 plus cos x. Therefore, pi of x is equal to 1 by 2 of 3 plus cos x. Okay? So we have the function here. Next, what we have to do? We have to calculate the pi dash of x. So pi dash of x means obviously 3 by 2. So it can be written as 3 by 2 plus cos x by 2. Now take the differentiation pi dash of x. 3 by 2 means 0 plus 1 by 2 cos x derivative is minus sin x. Now pi dash of x is equal to minus sin x by 2. Now apply the modulus on both sides. Then what we get? Simply we will get that sin x by 2. Now here we have to substitute one value in this one, right? So already we know that, otherwise we have modulus. Okay. So now we know that we will get it as nothing but positive and 1 by 2 outside, then which is equal to modulus of sin x. Then what will happen when we are taking modulus of sin x, we will get that less than or equal to. Now pi dash of x is less than or equal to 1 by 2 and we know that it is 1. Okay. So because we know that modulus of sin x is less than or equal to 1. So simply here I substituted it is nothing but 1. Okay. Now here 1 by 2. 1 by 2 means can I say that it is strictly less than 1? Yes, we can. So therefore write down. Therefore here pi dash of x is less than 1. Okay. So now here what we have to do? We have to choose one x naught. Right. Now choose x naught. So now here I have to choose the value of x naught which lies in the interval, and the interval is 1.5 to 1.57, very near interval. That's why directly I am taking that 1.5. Okay. Now xn equal to, I am writing the formula. Now pi of xn minus 1, xn n equal to 1, x1 equal to pi of x naught. Then x1 equal to what is x naught? This is nothing but pi of x. Okay. So now here 1 by 2 of 3 plus cos x naught. That means 1 by 2 of 3 plus cos 1.5. Now I am calculating this value. 3. Okay. Cos, first of all calculate cos 1.5 plus 3 divided by 2. Now it is nothing but 1.53536. So I am taking that 54. Up to 4 decimals they ask. So minimum we have to take 4. Now this is nothing but x1. Next x2 equal to pi of x1. Pi of x1 means what we will get, ma? Simply it is nothing but 1 by 2 of 3 plus cos 1.5354. Now calculate it. Cos 1.5354 plus 3 divided by 2. Now it is nothing but 1.51769 means 77. So the value is of course 1.5, but after this one we have the second digit is 354, but here we have 177. That's why we have to go for the x3. Now 1 by 2 of 3 plus cos 1.5177. Now what we get? Calculate it, ma. Cos of 1.5177 plus 3 divided by 2. Now I have that 1.56, sorry, 1.52. 52653. So simply I am taking that 65. This is nothing but x3. Now x4 equal to 1 by 2 of 3 plus cos of 1.5265. Okay. Now write down. Calculate cos of 1.5265. Okay. Plus 3 divided by 2. Now 1.52214 I have. So simply I am taking 1. Up to 52. Yes, it is same. But the value we have to check up to 4 decimals. So that's why again x5. 1 by 2 of 3 plus cos of 1.5221. Then simply cos of 1.5221 plus 3 divided by 2. 1.5243 3 again, so simply it is nothing but. Now see, up to 5 okay, it is similar. Now I am going to calculate again same x6 value, okay. So now here x6 equal to 1 by 2 of 3 plus cos of 1.5243. Now cos of 1.5243 plus 3 divided by 2. 1.52323. So I am making that 3 2. This is x6. So here x5 is 1.5243 and here we have 3. So I am going for the next iteration 1 by 2 of 3 plus cos 1.5232. Now cos of 1.5232 plus 3 divided by 2. Again here 1.52378 I have. So simply 38. Now it is nothing but x7. Of course, see here we have 5 to 4 and here we have 5 to 3, 5 to 3. Almost same. Now I am going for the next iteration 1 by 2 of 3 plus cos 1.5238. Now cos of 1.5238 plus 3 divided by 2. 1.52348, so it is nothing but 35. Yeah. So now here obviously here we are getting that the root value is nothing but 523 8 and 35. Of course those are very near values. If you want then you can calculate the value. Otherwise next you can go for the next iteration x9. 3 8 means 4, 5 to 4 we can take, 3 5 and means of course 4 we can take, but here I am calculating one more iteration. Cos of 1.5235 plus 3 divided by 2. 1.5236 39 I have, so 5x9 is the value. Now here for this one of course it is a very near value, right? So now here I am calculating the error. x9 minus x8 is nothing but 1.5236 minus 1.5235. The error is very less value, 1 point of course 0.0001. Okay, so it is nothing but the very small value, right? So that's why here I am checking that the required root, therefore the root is 1.5236, which is nothing but approximately equal to 1.524. Okay, so therefore this is nothing but the required root. Next, okay, so I hope it is clear. Now the simple thing, we have to take the value and next we have to calculate the next iteration by substituting the previous value. Okay, so and in the next class we are going to discuss the next application, and we have 2 more applications. After this we will go for the next method. Okay, and I hope it is clear, ma, and if you will get any doubt then please ask me. Thank you everyone.